Okay, so we saw precipitation reactions produce a solid as one of the products. We talked about the neutralization reaction, and I told you it's a reaction, or the acid-base reaction is another name. You have the acid and the base reacting to form water and a salt. So just to look at acids and bases real quick, and then we'll talk about the neutralization reaction. So we've talked about acids. We know that acids produce hydrogen ions when they're dissolved in water. That's why when we were doing naming the acids, I told you it has to have an AQ next to it, because that shows us it's dissolved in water and it's producing those hydrogen ions. So if it produces one hydrogen ion, we call it a monoprotic acid. If it produces two hydrogen ions, we call it a diprotic acid. So you can always tell, by the subscript. So there's, the one there, the two here. And if I had phosphoric acid, then it would be triprotic. So all that's doing is telling you how many hydrogen ions are being produced. Okay, a base produces hydroxide ions in water. So you can have, So you can have something like a metal with the hydroxide ion, and when you put it into the water, so here's M just represents the metal with the hydroxide ion. When you put it into water, hydroxide ions are produced. Or you could have something like ammonia, putting it into water, then hydroxide ions are produced. So as long as hydroxide ions are being produced, then or it's increasing the amount of hydroxide ions, then it is a base. Okay, so we said for the neutralization reaction or an acid-base reaction, that's exactly what it is. We have an acid reacting with a base, and it produces water and salt every time, okay? Because what's happening is the acid has the hydrogen, right? That's what makes it an acid. The base has the hydroxide. That's what makes it a base. So when I get hydrogen and hydroxide together, it forms water, okay? So don't write HOH. Okay, that's wrong. It's water. So wrong, okay? So that's why you always get water. And then the salt is just the cation, the anion from the acid and base. So it just depends on what acid base we have. Okay, so you should be able to do the same thing that we were doing with the precipitation reaction. Is if you're given two reactants, you should be able to figure out what the products are by doing the cation switching anions. And then you can do the ionic equation as well, and then the net ionic equation. But the nice thing about the acid-base reactions is this is always the net ionic. You don't even have to figure out what the molecular or the ionic equation is. The net ionic equation for a neutralization reaction will always be hydrogen ion plus hydroxide ion producing water, always. But if you forget, you can still get there if you do the molecular and then the ionic equation as well. So I'm just going to make up an example here for you and do it real quick before we move on to the gas-forming reactions. Okay, so let's say we have, we'll say sulfuric acid, not a 3, I meant to write a 2. Okay, here's sulfuric acid. Be careful with these on your homework. They get a little tricky. I'm not going to do this on the test, but in your homework, if it is a weak acid or a weak base, then you have to show that in your equation, okay? So just be careful. They do that with your homework, okay? Again, I'm not going to put that on the test. I just want you to we'll just use strong acids and strong bases, okay? Okay, so we have sulfuric acid, and let's do lithium hydroxide. Okay, so we have a strong acid, strong base. Okay, so we're going to figure out what the products are. So we're going to take the cations. Those are the cations. So we have hydrogen ion, right? I'm not going to bring that 2 down. The 2's there because of sulfate. And then lithium ion. Wow, that doesn't look like it now. Okay, lithium ion. Okay, now they're going to switch cations. So sulfate is going to go with lithium. Okay, sulfate has a -2 charge. And then hydroxide is going to go with the hydrogen. It's a negative. So here again, it's not HOH, it's going to be H2O. So it's going to be our water. And water is always going to be liquid here. Okay. And then we have Li2SO4. So remember to do our switcheroo. So the 2 is going to come over here on lithium, the 1 on sulfate. Okay, so then we use our solubility table, and we see that sulfate is soluble and lithium is not an exception, so we can write AQ. Okay. Okay, and that's it. And then again, we could go through and do the ionic equation as well, but for now we would do the molecular. So the only thing missing, let's see here, let's make sure it's not balanced, so let's balance it real fast. Okay, so remember, it doesn't matter what's on the product side or which comes first. That's what I meant to say. What comes first? It can be water, it can be lithium sulfate, it doesn't matter. Okay, so we have 2 lithium on the product side. We need 2 lithium on the reactant side. Now we have 4 hydrogen on the reactant side. We need 4 hydrogen on the product side. We have 2 oxygen. We have 1 sulfate. Okay, now it's balanced. Okay, now let's look at gas-forming reactions. Now these are a little more difficult than the precipitation reactions or the neutralization reactions, because what happens is when we have the cations switching the anions, they form an intermediate product. So that intermediate product can be a little tricky, okay? So if you look here, we have, these are our reactants and these are our products. Okay, we have 2 aqueous products. Now you shouldn't be getting that, okay? And if you have aqueous all on the reactant and the product side, that means you have no reaction. So that's why this one's tricky, because if you don't know about the intermediate product, you would look at this and say nothing happened. There was no reaction. Okay, but H2CO3 is our intermediate product, and it does form, but then it immediately breaks into water and a gas. So let's look at, we have a few of these intermediate products here. Okay. So we're going to get an intermediate product when a carbonate or bicarbonate react with an acid. So just to show you, okay, carbonate is CO3, retry that, 3, -2. Bicarbonate is HCO3 with a -1. Okay, that's carbonate, bicarbonate. When they react with an acid, they'll form that intermediate product. When we have sulfite, sulfite is SO3, -2. Okay, when that reacts with an acid, it's going to produce that intermediate product. And then when we have ammonium, so ammonium is an H4. When it reacts with hydroxide, which is OH, it's going to produce an intermediate product. And then sulfides and cyanides, they don't produce an intermediate product, but they do produce a gas. So when they react with acids, they produce a gas. So here we have sodium sulfide reacting with an acid, and it produces hydrogen sulfide gas. Okay, we're not going to do a lot of that. We're going to stick with the first 3 really. But, I mean, you can form gas products without that intermediate product. Okay, so here's what it looks like. Okay, here's carbonate with an acid. So we have H2CO3 is one of our intermediate products. Switch to red. Okay, and bicarbonate with an acid forms the same intermediate product. So really all you have to remember is H2CO3 breaks into water and CO2 gas. Okay, then we have sulfite reacting with an acid, that forms the intermediate product H2SO3, and that breaks into water and SO2 gas. So really, if you're having trouble remembering what the gas that's being produced is, so get your intermediate product here, H2SO3, subtract out water, okay, subtract out 2 hydrogen, 1 water, and that gives us SO2. Okay, same thing up here, H2, CO3, subtract out water, and that gives us CO2. Okay, and then last one, we have ammonium with hydroxide, we get NH4OH. We're going to subtract out water, and that gives us NH3, ammonia as our gas. Okay, so that's a nice little trick to have. If you can't remember what gas is produced, just at least remember these 3 intermediate products, because remember the first 2 up here are the same. So H2CO3, H2SO3, and NH4OH. So make sure to memorize those intermediate products and then know that they're going to produce water and a gas. Okay, so I have them here in these equations. So I just want you to see, you can see you have the acid, we have the hydrogen, and the carbonate. So that comes together to form our intermediate product, H2CO3. So we're not done with these equations, we just have the intermediate products in there for now. Okay, we have ammonium and hydroxide, here's our intermediate product. Bicarbonate and acid, there's our intermediate product. Sulfite with the acid, there's our intermediate product. So we can't leave these reactions like this. Okay, if you look, all of the states are aqueous. Anytime you have all aqueous states, it means there's no reaction occurring. Okay, but that's not the case because we know they're going to break into water and a gas. Okay, so that's what we have on the next slide here. So I've taken those intermediate products and made the water and gas that they produce. So this would actually be what it looks like. Okay. Let's do... Okay, well, let's do these real quick. So we're going to write a balanced molecular equation for each of the reactants. So I'm going to do it on this here. Okay, so first we have Mg. Let's do one of the gas forming. Number 2. So we have H. Oh, for goodness sake. Okay, I'm not sure why I did that. H2CO3. Reacting with potassium sulfite. Okay, so we want to figure out what is being produced. Okay, so we're going to take our cations, hydrogen and potassium. So hydrogen ion is just H+, so we're not going to bring that 2 down because that came from carbonate. And then potassium is just K+, same thing. We're not going to bring the 2 down because it was from sulfite. Now we're going to switch our cations. Sulfite is going to come with hydrogen and carbonate with potassium. Okay, so we're going to get H2SO3. So that's where we recognize, okay, here's our intermediate product. Okay, so we know we're going to get water, and then we're going to get the gas. So if I subtract out water, I'm left with SO2. So I have SO2 gas. Okay, and then my last product is right here, K2CO3. Okay, so I can look up that one to see if it's soluble. So if at the very top it says potassium is soluble, and there are no exceptions. So this will be AQ. Okay, so we can put all that up here. And again, it doesn't matter which order you put the products in. Okay. And then K2 CO3 aqueous. Okay, then last thing to do is to balance. Some of this out of the way. Okay, to balance. So we have 2 potassium, 2 potassium. We have 2 hydrogen, 2 hydrogen, 1 carbonate, 1 carbonate, 1 sulfur, 3 oxygen. So it's balanced. So we're all done. Okay, so let's go back and do that first one. I just wanted to make sure we got one example of a gas forming reaction. So this one we have magnesium hydroxide. So remember, magnesium hydroxide, it's not a strong base, okay? But we're not going to do we're not going to include, well, we can do that. We'll include it. That way you can see it for your homework. Okay, so we have magnesium hydroxide. It's aqueous. And then HBr, aqueous. Okay, so we're going to figure out the molecular equation. So the only time you really need to worry about the weird stuff for weak electrolytes is when you're doing the ionic equation. Okay, so HBr is a strong acid, but magnesium hydroxide is a weak base. Okay, so we're going to take our cations. So we have magnesium plus 2 charge and hydrogen plus 1 charge. So we're going to switch our anions. So bromine is going to go with magnesium. And hydroxide is going to go with hydrogen. So I'm not going to bring that 2 down because it was from magnesium. So I'm going to get MgBr2 and water. So water is going to be a liquid. Okay, so just put an L. MgBr2, so we see bromine is soluble, magnesium is not an exception, so it's aqueous. Okay, so we can rewrite them up here. MgBr2 plus H2O, liquid. And then we need a balance. So we need a 2 in front of HBr because we have 2 bromine, 2 bromine. Over here on the reactant side, we have 4 hydrogens, so we're going to need a 2 in front of our H2O. That gives us 4 hydrogen, gives us 2 oxygen, 1 magnesium. That's it. Now it's balanced. Okay, now we have NaOH. Oof. Let's try that again. NaOH. It's aqueous. It's a strong base. Okay, and then iron 3 chloride. Okay, it is aqueous. It's an ionic compound. Okay, so we're going to take our cations. So we have sodium, has a 1+ charge. Iron's one of those that has multiple charges, but because of the 3 on chlorine, we know it's a +3 charge. Okay, so you're going to have to remember all that stuff you learned in Chapter 2 and this for Chapter 4 as well. Okay, so now we're going to switch our cations. So chlorine is now going to come with sodium, so I'm not going to bring the 3 down. The 3 is there because of iron. Okay, and then hydroxide. So we get sodium chloride. So sodium chloride, if you look up on your table, is aqueous. And then iron 3 hydroxide. Oh, good grief. Whoa. I don't know where that came from. Okay. Iron 3 hydroxide. Okay, hydroxide is insoluble. Iron is not an exception, so it is insoluble. It is a solid. So this is a precipitation reaction. Okay, so I'm going to rewrite these up here. And iron 3 hydroxide is our precipitate. Okay, so now we need to balance. Okay, so we have 1 sodium, but we have 3 chlorine on the reactant side. So we need, oh, still erasing. Let's try that again. Okay, we need 3 chlorine. 3 chlorine. So now we have 3 sodium. We need 3 sodium. 3 hydroxide, 1 iron. Now we're balanced. Okay. Now the next one we have NH4Cl, aqueous, plus KOH, which is aqueous. Okay, we're going to take our cations. We have NH4 plus 1, and potassium is a plus 1. Switch our cations. So hydroxide is going to come here. It's a negative 1. And chlorine down here is a negative 1. So we're going to get NH4OH. So there's our intermediate product we were talking about, NH4OH. And then KCl. Okay, so we need to subtract out the water. So we're going to get water and a gas, so H2O, and then what's left is NH3. That's our gas. Okay. KCl, if you look on your solubility table, is soluble, so we're going to put AQ, and then we can put everything up here. So we have water plus our gas. Now, if you were doing a ionic equation, so your H2O and your NH3, you would not break apart into ions. Okay, you only break up aqueous. So since water is a liquid and NH3 is a gas, you would just leave it alone. And then we have KCl, aqueous. So we would break apart KCl. Okay, and I believe everything is balanced. Let me just double check here. Okay, yep, everything's balanced. Okay, next one. We have COCl2, so cobalt 2 chloride. It's aqueous plus silver nitrate. It's aqueous. Okay, we're going to figure out our products. So we're going to take our cations. So we have cobalt has a plus 2 charge, and I know that because of the 2 on chlorine. And then silver has a plus 1 charge. Okay, so they switch. Nitrate comes over here with cobalt, has a negative 1 charge. And then chlorine comes down here with silver. And I'm not going to bring that 2 down because the 2 is only there because it's combined with cobalt. Okay, and then we form our products here. So we're going to get cobalt, NO3, 2, and then AgCl. Okay, so now we look at our solubility table and we see that nitrate is always soluble. So we're going to put AQ. Chlorine is soluble except when it's paired with silver. So we're going to give it an S because it's insoluble. Okay, so I'm going to rewrite these up here. I'm going to have to erase this. Okay. CONO3 to aqueous. Okay, so we want to balance. So we have 2 chlorine on the reactant side. We need 2 chlorine on the product side. That gives us 2 silver, so we need 2 silver on the reactant side, which also balances our nitrate, which we have 2 of. And then cobalt, we only have 1. So we are balanced. Okay, last one. We have HBr, which is a strong acid, and calcium hydroxide, which is a strong base. Okay, so we're going to take our cations. We have hydrogen, and then calcium. Calcium, oh, for goodness sake, has a +2 charge. So now we're going to put hydroxide with our hydrogen, bromine with our calcium. Okay, so we're going to get water, which is a liquid, and calcium bromide. Okay, and if you look up calcium bromide on your solubility table, bromine is soluble. Calcium is not an exception, so it's aqueous. Okay, so I'm going to rewrite these up here. H2O, liquid, and calcium bromide, aqueous. Okay. Okay, so now we'll balance. So we have 2 bromine on the product side. We need 2 bromine on the reactant side. So we need a 2. We have 4 hydrogen on the reactant side. We need 4 hydrogen on the product side. And that is it.